using our notes from the previous page, ones that we've seen earlier this year, we're going to take this first logarithm that we have here, and we're going to be writing it in exponential form. In other words, I'm going to be writing it in a form that looks like that. So in order to do so, the first thing I need to know is I need to know the base. In an exponential form, the base is whatever's raised to a power. The base of a logarithm is also right there. That's called the base. The base is the number that's written smaller and lower right after the logarithm. So in this case, we're going to start by writing n, and it's going to be to the power of something. The way I always remember it is I remember that log equals the exponent. And so it's going to be n to the power of c. Then equals, then it equals k. Notice how this form and this form are very similar to each other. It's just different letters in there. Both of those are what we would call exponential form. All right, for the second problem now, we're going to be writing this now in logarithmic form. And so that means I'm going to be taking something like that, and I'm going to be rewriting it in something that looks like that. That's logarithmic form. So if we're going to do that, as you can see up here, the very first thing that I'd write then is log. So we write log first. The next thing we write in our logarithm is the base. Well, remember on the last one, I was talking about how the base is whatever is raised to the power. In this case, the m is being raised to the power of something. So the base of my logarithm will be m. So it's log base m of, notice here, it was the k. Notice where that k came from in the exponential. That's the one that was by itself. And so similarly, that's got to be what the d is doing right here. So it's going to be a d in the parentheses. And then that's equal to, well, whatever's left, which is convenient because log always equals the exponent. And that is the exponent there is what we are left with there. As long as you remember that log always equals the exponent, you are halfway there in being able to write these in the other forms. The other half, I'd say, is remembering what the base is. And remembering that the base of a logarithm and the base of the exponential both mean the same thing. Now to calculate these values, we need to use that change of base formula. So the change of base formula says that log base 3 of 21 here is going to equal a log over a log. Usually the only tricky part is just remembering which number goes on top and which number goes on bottom. The way that I remember it is I remember that the base goes on the bottom, but if you want to, you can also see a visual hint because, of course, whichever one is lower in our fraction is also going to be the one that is written lower in our logarithm, and that is the base. So the 3 goes on the bottom, which means that the 21 goes on top. Notice they are not in the same order as when you read them from just like left to right, but rather we have to go base on the bottom. All right, now it's just a matter of actually doing that calculation, plugging it into your calculator. So give that a try, and let's see how you do with it. If all goes well, you should be getting an answer here of about, and so since it's approximate, I'm going to make those into an approximately equal symbol, 2.77. Now I'm just rounding to 2 decimal places here. There's nothing magical about that. It's just a nice fallback. All right, on to the next problem. So we're going to calculate this one, and it's going to work the same way, where in order to calculate this value, I have to actually use that change of base, which means doing log divided by log. Now, which one goes on top and which one goes on bottom? Well, the base always goes on the bottom. In this case, the base is the 20. And so the 20 goes on the bottom. And then that means the 6 is on top. Again, notice the 20 was written lower, and so the 20 ends up being written lower in our fraction as well. All right, now I'm going to plug this in my calculator as well and figure out what that is. And I get about 0.598. Well, the 598 would then round to 60. So that's going to be 0.6 basically for our final answer on that one.